Alright, today we learned about functions, so we're going to determine whether a relation is a function, and then we're going to use functional notation and simplify them. So first thing that you want to note is the domain is your first coordinate. It's usually the x coordinate, and we can ignore these numbers here. The range is the second coordinate, which is usually the y coordinate. So if I gave you a set of ordered pairs, which is known as a relation, then we would say the domain, in this case, is our first term in each of our ordered pairs 1 and 8, and our range would be represented by the second coordinate 7 and 10. A function is when each element of the domain is paired with exactly one element of the range. And there's a couple other ways to write this. You can say that there's 1x for every 1y. And then I like to use this. You cannot have the same value of the domain, and sometimes I say that all domain values must be different. So we're going to look at some situations to determine whether or not things are functions. We have what's known as the vertical line test. This says if a vertical line intersects the graph of a relation at more than one point, then the relation is not a function. So we're going to look at this one. If we were to draw a vertical line at any point, it's not too straight, but if we draw a vertical line, how many times does it pass through this blue curve? Right here we can see it passes once. Now if we were to slide that line at any point on the graph, so here or here, or any point on that graph, if it only passes through one point, then we consider that a function. So here we would say, yes, this is a function. Now when we look at the second one, we're going to look at that blue kind of zigzag line. If I were to draw a vertical line right here, you would see that it passes through once. If I were to draw it here, that vertical line passes once. But what if I were to draw right in the middle? Right there, you can see that it passes multiple times. So if it passes through more than once, it is not a function. We would say that this is not a function. Some other examples of not functions. If we were to have a graph that looked like this, that vertical line would pass through 2 points, so that would not be a function. A linear equation is a function that can be written in the form of y equals mx plus b, or this is what we call function notation, which reads f of x equals mx plus b, where m and b are real numbers. So I have a bunch of examples of linear and not linear. As we look at linear, this is what I try to show kids. If you have an exponent and all of these exponents are 1, you're most likely going to get something linear. Not linear. Here we can pick out the exponent is squared. That will give you something that is not linear. On the second equation, we have two variables that are multiplying to each other. If they multiply to each other, you're not going to get linear. On the third example, we're dividing by a variable. If you divide by a variable, it will not give you something linear. And on the last one, if you take the square root, then it is not linear. Okay, so examples of things that are not functions, if you have a plus or minus, this graph ends up looking like this. This will show you that it does not pass the vertical line test. On the next one, if you were in the coordinate plane, it would graph like this. And it is a vertical line. A vertical line will not pass the vertical line test. It says that every value of x is 3, and it's listed multiple times. And according to our definition, all the x values or all the domain values have to be different. These are all the same, so it is not a function. The third example that I have here, you have an x squared and a y squared, and what this does for you is it creates a circle. And a circle is not a function because it doesn't pass the vertical line test. Here it passes through twice. So, example 2 says, is the given relation a function? Is it linear? Explain. So the first thing we're going to do is look, because we haven't ordered pairs, we're going to look, are all of the domain values different? If they are not different, it's not a function. So here we have a 1 that's listed twice, so it is not a function. So we're going to say function, no, and we'll say the domain values are the same. Linear. If we're not sure about linear, we can always graph these points. So the first one says over 1, up 3, over 4, up 7, up here, and over 1, down 8, which will be somewhere down here. We can see that they do not form a straight line, so we would say no. The points do not create a straight line. Okay, we go to B. Again, to determine if it's a function, you're going to look at your x values. If they are all different, or the first value in the ordered pair, if they are all different, then it is a function. We can see that those 3 values are different. So we're going to say function, yes, all domain values are different. Linear is what we're going to look at next. So again, we can graph those. The first one says that we're going to go back 2, up 4, so about here. Maybe. The next one says over 5, up 4. Last one over 12, up 4. And we can see that, hey, those do make a straight line. So we will say, yes, it's linear. And the points create a straight line. On C and D, function, first of all, we're going to look at that. Is it a function? Right here it only passes, well, I kind of missed, but here it only passes through 1. But if we slide that vertical line over here, it's going to pass through more than 1, so a function, no. We'll say it doesn't pass the vertical line test. We're going to call it the VLT, which we thought was really kind of funny in class. Then, is it linear? That's easy to see. No, it's not straight. A portion of it is, but the majority of it is not. Okay, on D, we're going to look at it. Is it a function right here? This will tell you no. It does not pass the vertical line test. Linear, and here it's no, it's not one straight line. We'll say a continuous line. Alright, on example 3, you're going to evaluate the function for x. So I have 2 different functions, f and g, and we're going to use this function notation. On A it says we're going to start with the f function, so this function, and wherever there is an x, we're going to replace with this -3. So I'm going to take all of this, and wherever there is an x, I'll circle them. We're going to replace that with a -3. So my first one I replace with the -3, and it's squared. -4 times -3 plus 1, and then we're going to solve that. So -3 squared is 9, and then -4 times -3 is 12 plus 1. 9 plus 12 plus 1 is 22, so we would say f of negative 3 is 22. Sometimes you'll hear it say that if negative 3 is the input, then 22 is the output. So what we put into the function, this is what we get out of the function. Another way to look at it is you can make it an ordered pair. If I were to graph this function, then this point right here, negative 322, would lie on the function. Okay, whoa, I thought I was erasing. Okay, for B, this says we're going to take the g function, and wherever there is an x, I'll circle it, we're going to replace that with this 2. So we take negative 3 times 2, where the x is, and then add 4, and then we just simplify that. Negative 3 times 2 is negative 6, add 4, and we get negative 2. So g of 2 is equal to negative 2. We're going to continue this. This says we're going to take the f function, put 4 in, and then in the end, we're going to subtract 1. So I'm going to take this f function, wherever there is an x, I'm going to replace it with the 4. I'm having a hard time writing on this, sorry. So there's our function, then in the end we have to subtract 1. So we get 4 squared is 16 minus 16, 4 times 4, plus 1 minus 1, and this will give us 0. So our function f of 4, and then when we subtract 1, gives us 0. D is a little different. It asks you to replace a variable with another variable. So we're going to go and replace this x with a 5w. So I will write negative 3, and the x we're replacing with 5w, and you'll add 4. So negative 3 times 5w is negative 15w plus 4. And that does not simplify because these two are not like terms. So that would be your expression g of 5w is equal to negative 15w plus 4. Alright, this should help you with your 6-1 functions worksheet. Good luck.